Well, how are you, everybody who is connected with this serious engineering class? If the first time to meet me, my name is Olenjolai. I am a Tanzanian. I'm very committed in teaching and electronics and telecommunication engineering business. So I'm very happy to welcome you into lecture 2 of power electronics, where we are going to discuss some different concepts. And I want to tell you that you have to concentrate and you have to take it serious, because this is the very important field of electronics. I would like to welcome first year students, second year students in engineering, and for science, electronic science, yeah. However, that will be diving into engineering a lot more than science. So these contents might help even advanced secondary students who are actually preparing to go for the engineering field, especially any electronics engineering field or related field, such as telecommunication engineering, computer engineering, biomedical equipment engineering, mechatronics engineering. So we have covered some lectures before, that lecture 0, lecture 1, and then this is lecture 2. And we still have a number of lectures, a number of workshops in simulation, and a number of experiments in real-world environment. One thing which I want to tell you, be serious, be committed, and we are always discussing the concept from the fundamental up the intermediate. In this course, we are not going to discuss about advanced concepts in power electronics. We'll be just discussing the fundamentals and the intermediate concept, which actually you may go further to the advanced part, but it may take time, and something you may not understand according to the level of the information or according to the information that you have. So I have some physical students in this class, and also I think that I have some students who are not connected in this class or are not a part of this class. But all in all, I believe that you have fresh mind. This is a serious business. Have your exercise book specifically for power electronics. Have your pen, have your pencil, have your ruler, because we'll be having a number of diagrams which actually you have drawn by using a pencil, and make sure that also you have a rubber. So if that's the case, then let us into our lecture. But before we go into lecture 2 or the quick review of lecture 1, I would like to appreciate some physical students who actually are the part of this class. And then after that, we'll start our today's lecture. And I want to tell you that electronics is beautiful, and electronics is a wonderful business. You have to be happy all the time when you're learning electronics. But if you're not happy, I'll try my level best to make sure that I convince you to be happy in this business. Because first of all, you have to be happy. Most of the concepts are not simple. So if actually that you are ugly or you are angry, you know that you will not understand anything. So it's better for you to be happy to neutralize the equation. Okay? So how are you, electronics and telecommunication engineering students? Are you ready for lecture 2 of power electronics? Yes. Well, so if you are ready, remind us what we discussed in previous lecture. That was lecture 1. So in lecture 1, tell us, first of all, what was the title of the lecture? What was the title of lecture 1? Quickly, the entire class. What was the title of the lecture 1? Speak loudly, please. So we discussed about various terminologies of power electronics. Okay? Terminologies of power electronics. And then I told you that whenever you want to learn a particular skills or particular knowledge, you have always to start from fundamentals. Then, what the first terminology that we discussed? Engineering. So, how many definitions of engineering did I deliver to you? 2 definitions, right? The first one, why did we discuss engineering? Why we are studying power electronics? Do you think, ask your neighbor, why did we start with engineering and not what the meanings of power electronics? So your neighbor is smiling, eh? Well, so simply we say we have to start the meaning of engineering in order to understand what will be focused in power electronics. And simply I gave you a simple definition from MIT professor. What is engineering? We say simply is the purposive use of electronics of science. It isn't. Yeah, so it's a purposive use of science. In the second definition, also we added something in your mind. We say engineering, first of all, is a branch of science and technology, right? Which deals with application of mathematics and science to solve real life problem. Real life engineering or electronics engineering problems. That's the meaning or definitions of engineering. So yes, he came to learn how to apply mathematics and science to solve a particular real life problem in your community. And that day I asked you that, ask your neighbor, do you have a real life problems in your community that you want to solve? After education of the 4 years in bachelor degree of electronics and telecommunication engineering, I think you asked your neighbor and said, yes, I have. This isn't. So today you may ask your neighbor, my neighbor, tell you, my neighbor, how far have you gone on solving that real life problem? So reply your neighbor's question. I know the response is zero distance or 0 far, isn't it? Yes, because you are thinking about assignment, you are thinking about test 1, you are thinking about practicals, that's all. How to do that, how to do this. You are not thinking about solving a real life problems in your community. Do you know it, first of all? You don't know, eh? Do you know it? Can you tell us, public? Not today. Okay, good. Then the next terminology is electronics. So we wanted to narrow from general concept of engineering. Then we say, what is electronics? Simple electronics is a branch of engineering and science. Pardon? You told me that you are ready for lecture 2 and you forgot what you learned in lecture 1. So how will you receive the new information that I have today? So read. Electronics engineering is a branch of science and engineering. Discipline. So this is the study actual of of semiconductor devices that process what? Process electric current. Electric current carried or transferred by electrons and the holes. I told you that you should not claim definition. Understand the keywords, then use your own words. Okay? And then we discuss here another important terminology called the electronics what? Electronics what class? Engineering. Say electronics engineering. Say electronics engineering. So simply electronics engineering, this is the purposeful use of what? Use of electronics science. And then I asked you, go and ask your other classmate. Your other classmate, BNG 2481 and BNG 2482. Did you do so? Did you ask them? They gave you interesting definition. First of all, they give you a smile. That, are you serious? Are you asking a university student what is electronics engineering? That's a simple question for a university student. Then after that, no any sentence, right? Yeah. Then another terminology is called what? Power. What is power in context of electrical engineering? Power is the rate of what? Work done. Or power is the rate of energy. Energy transferred. Or power is the rate of energy what? Transferred. So energy transferred or energy converted. Then we discuss the last terminology, which is very important now. Then we define the meaning of our module that called the power electronics. Okay? So what is power electronics? Class define power electronics. The entire class define power electronics. First of all, stand up, all of you, because you are not serious. Stand up. Then define what the meanings of power electronics quickly. No. 1, 2, 3, go. Read it from your exercise book, because as I am 1, 2, 3, go. You're always finishing, right? Very good in finishing. And the last word is what? Devices. So we hear the amplified signal. But in the middle of the definition, just devices. Have your seat. Then I gave you examples of power, electronics, what? I gave you example of power, what? Power electronics, what? Power electronics conversion. So where are my material? Okay, just leave it. Let me just. So then I left here a question or just an assignment for you to go and discuss some other terminologies. So let us discuss about other terminologies which are very important. And this is terminology number 6. Is called the power electronics devices. After understanding the meaning of power electronics, then right now let us discuss and understand the meanings of power electronics devices. Say power electronics devices. Power electronics devices. Say with a very wonderful smile, just like if somebody gave you a gift. So this is the gift. It's today's gift. Say power electronics devices. Power electronics devices. Can you prove that your neighbor is smiling? Smile on behalf of your neighbor. I know your neighbor's smile is expensive. So ask your neighbor, how much should I pay you to smile? So, what is power electronics devices? Say again, power electronics devices. Power electronics devices. Well, you can have two definitions of this terminology. Power electronics devices. So when I'll be teaching you, you will be correcting yourself the homework that I left you for you. That's the goodness of higher level learning. You are just given a homework and then you mark for yourself. Is it good? Yeah. So power electronics devices are semiconductor. So these are semiconductor. Power electronics devices are semiconductor based components. So based components are semiconductor based components that are used to convey, that are used to convey, to control, to control, and what? And condition, and the condition. And condition electric power. And condition electric power in various applications. In various applications. In various applications. In various applications. That the meanings of power electronics. Or some of the articles or references define power electronics devices. Power electronics devices. Power electronics devices are the electronics devices that use solid state, electronics, use solid state electronics to control. So these are the electronics devices. They are not electric devices. To control and they convey electrical power. Used to control and convey electrical power. So those are the two definitions of, or two ways that you may define the terminology electronics or power electronics devices. Stop writing. Tell your neighbor stop writing. Tell your neighbor stop writing. Listen and watch. Power electronics devices, these are semiconductor based components. They are not conductor based components. They are semiconductor based components. And then what the main function of these semiconductor based components, because you have so many semiconductor based components. These are the semiconductor based components that are used to convey electrical power. Also, these semiconductor based components may be used to control electrical power, and also may be used to condition electrical power in various applications. In various what? In various what? In various what? So these are the semiconductor devices. We have so many semiconductor devices, but some of them we call them power electronics devices. And what the main function of those semiconductor devices, actually they are responsible to control electrical power. They are responsible to convey electrical power from one form to another form, and also they are responsible to condition electrical power in various applications or in various industries or in various electronics systems. Okay? 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 Or in other words, power electronics devices are the electronics devices that uses solid state electronics. Solid state electronics. When you say solid state electronics, means that semiconductor. So AKA of semiconductor is solid state. Hello? Hello? Stand up. Stand up. You. Stand up. Yes. Stand up and look on the blackboard, because we are looking at what is your neighbors has been writing. So when you say solid state electronics, we mean semiconductor components or semiconductor devices. So these solid state electronics components, they are used to control electric power, and also they are used to convey electric power from one form to another form. Remember that I told you that power electronics is not another type of power. Power electronics is actually, we say that, the use of semiconductor devices to control or convey or condition electric power. So remember that in electronics, we don't have electric power and power electronics. No, we just have electric power. But in case of power electronics, we'll be discussing about how we can use semiconductor devices to convey electric power, to control electric power, to condition electric power for the particular application. Are we together? Yes. Are we together? Yes. So let us reinforce understanding. I don't want you to claim or spend all night reading about these definitions of electronics power electronics devices in your mind. So 1, 2, 3, go for the first definition. What is power electronics devices? Okay, class. 1, 2, 3. Read the first definition of power electronics devices. Yeah, I'm happy. But my friend there, the distance between the upper copper and lower copper is negligible. So he was trying to convey. Okay? So, where do we use these concepts of power electronics devices? So he said that these power electronics devices are designed to handle what? High voltage. Say high voltage. Say high voltage. High voltage and high current. Ask your neighbor, are you high voltage or high currents? Ask your neighbor, are you high voltage or high current? Eh? Who is your neighbor? Eh? Do you know the name of your neighbor? Do you know the real life that electronics engineering real life problem that she wants to solve? No. Aha. So he said that these power electronics devices are designed to handle. Are designed to what? Are designed to what? To handle what? Hello? Stop writing now. Stop writing, stop slumbering. Look on the blackboard and listen. These power electronics devices are designed to handle. Say to handle. High voltage and high currents. Oftenly far exceeding those in typical low power what? Electronics. Remember that we discussed in lecture 1 that the formula of electric power, which we call TP, we say this is equal to the product of what? Of current and what? Voltage. So simply we say that power is equal to current, which is I, the symbol is I, times what? Voltage. What do you think that if these power electronics devices are... So you are writing. I say that stop writing. Please help your neighbor to stop writing. Then, if that's the case, we say that, for instance, if these power electronics devices are designed to handle high voltage and high current, Then what do you think? For instance, you have high what? You have high, say high. Say high. You have high current multiplied by high voltage, let's say, or multiplied by low voltage, or high voltage multiplied by low current. What do you get? You have high current multiplied by high voltage. What do you get? You will get what? High power. So whenever we talk about power electronics, in most cases, we talk in terms of the voltage and the current, because the product between voltage and current, we get electric power. It's not electronic power, it's electric power. Are we together? Yes. No. Who said no? You? Who said no? Nobody? Yes, I like no. I want to know that what didn't you understand? The formula or the conclusion, what? Is it clear? It's not clear. Should I repeat? Should I repeat? Should I repeat? Even if one yes, I will repeat. Should I repeat? Okay, some said yes. Listen, we say that these power electronics devices, all students listen, whether you understood or did not understand. These power electronics devices are designed specifically to handle high voltage and high currents. Not all semiconductor devices handle high current, and not all semiconductor devices handle high voltage. Right? So when you find that this sentence, we are trying to prepare your mind and to enlarge your understanding capacity about power electronics. So it's not all, first of all, remember semiconductor devices are very good, or most of them are low power devices. So they can handle low current and low voltage. Hello, stand up. Stand up, do you see? Stand up. Stand up, quickly. So they can handle what? High voltage and high currents. That's why we call them power. So the product between high voltage and high current is high power. That's why we call them power electronics devices. They can handle large amount of electric power flowing through semiconductor devices. Are we together? So that's why I reminded you from the mathematical definition of electric power. Are we together? Yes. Then the next key concept that you have to understand after understanding the definition and the goal or the purpose of designing power electronics devices you have to understand about, or you have to learn about, what are the examples of those power electronics devices. You have to know them. Okay? That's the next one. I know the definition, I know the purpose why you have them in electronics engineering, and then the next question, can I know some examples to realize that I have a knowledge of those examples or I don't have? That's the next step. So then, if that's the case, ladies and gentlemen, 10 examples that I've asked you to find for, 10 examples of power electronics devices. 10 examples of power electronics devices. The first example of power electronics devices is called the diodes. Say diodes. Say diodes. When you talk about diodes, it means that general purpose diode. Let me specify. General purpose diode. We have almost 13. I used to teach my students in fundamental of practical electronics. I used to teach my students 13 examples, 13 types of diodes. So diodes is a broad field more than you think. You just know the p-n junction diode. Possibly maybe with Zener diode. Maybe with what? Light emitting diode. That's all you know. But there are 13 types of diodes. So one of that types is called the general purpose diodes. Say general purpose diodes. Say again, general purpose diodes. When you talk about general purpose diode, simply we mean p-n junction diode. And this one electronics we have, for instance, 1 1N, this is the diode number, 1N7001. This is we call it a diode number, or a general purpose diode number. 1N7001, 1N7000, 1N7002, 1N7003, 1N7004, 1N7005, 1N7006, 1N7007. Engineering is all about numbers. Tell your neighbor, engineering is all about numbers. Yeah, so you have to talk in terms of numbers. Leave a number of words. So general purpose diode. The second one is, the second example power electronics device is called the varactor or varicap. It's called the varactor or varicap diodes. Say varactor or varicap diodes. Again, because others have been writing. Say varactor or varicap diodes. The third example of power electronics devices is called the power bipolar junction transistor, aka we call it power BJT. Say power bipolar junction transistor. Again. Yourself? Alone? Brother? Alone? Tell us. Power. Say power bipolar junction transistor. Then the first example of power electronics devices is called the insulated gate. Insulated gate bipolar junction transistor. Bipolar junction transistor. Bipolar junction transistors. In short, it's AKA, we call it IGBT. IGBT. So say insulated gate bipolar junction transistor. That's the first example of power electronics devices. The fifth example of power electronics devices is called the thyristors. Say thyristors. Say thyristors. Say thyristors. So this one, in short, is called the silicon control rectifier. Silicon control rectifier. Or in short, we call it SCR. Say thyristors. Say again thyristors. So thyristor is just like a silicon. Say silicon control the rectifiers. Say it loudly with joy. Say silicon control the rectifiers.
Silicon control the rectifiers.
AKA? Madam there? Hello, madam. Say it to yourself. You. Don't turn beside you. Say it. So madam say, I don't see it. Okay. The sixth example of power electronics devices is called the insulated so we call it insulated, not insulated, sorry. So it's called the metal oxide semiconductor field effect. Field effect transistor. In short, we call it MOSFET. Class say metal oxide semiconductor field effect transistor. It's afternoon, so maybe you say that I did not eat anything since morning. So that's why that I don't have a lot of energy to push my voice. Say metal oxide semiconductor field effect transistor.
Metal oxide semiconductor field effect transistor.
Or in short, we call it MOSFET. Say MOSFET.
MOSFET.
Say MOSFET.
MOSFET.
MOSFET is a broad field of electronics. For instance, your mobile phone, it contains billions of your smartphone, so your iPhone contains billions MOSFETs. For instance, your computer, your personal computer, which we call sometimes laptop, consists of billions of MOSFET. We call them electronic switches, billions of them. So if it consists of billions, ask your neighbor, which one do you know among those billions? Then, the seventh example, we call it power field effect transistor. Simply call it power FET transistor. FET is the abbreviations of field effect transistor. We call them unipolar junction transistors. In electronics, we have bipolar, we have two types of transistors. Bipolar junction transistor and unipolar junction transistor. And then we have two types of bipolar junction transistor, which is NPN, bipolar junction transistor, and PNP, bipolar junction transistor. In case of the field effect transistor or unipolar junction transistor, we have also two types. We have field effect transistor, which is called FET, and also we have MOSFET, or metal oxide semiconductor field effect transistors. And then in case of the FET, we have two types of FET. We have N-channel field effect transistor and P. What are you writing? Now I'm talking, I will ask you those questions. We have two types of the field effect transistor. The first one is called N-channel field effect transistor or N-channel FET. And the second one is called the P-channel field effect transistor or P-channel FET. In case of the MOSFET, we have two types of MOSFET in electronics or metal oxide semiconductor field effect transistor. The first one we call it enhancement metal oxide semiconductor field effect transistor, or we call it enhancement MOSFET. The second type is called the depletion metal oxide semiconductor field effect transistor, or aka we call it enhancement MOSFET. That's what you have to learn in basic electronics engineering. You are thinking about passing exam. Well, keep on. So this is, say, power field effect transistor. Number 8. The 8th example of power electronics devices is called the silicon controlled. We have so many types of thyristors. One of them is silicon controlled rectifier. But silicon controlled rectifier, this is the independent power electronics device. So called the SCR. Electronics or silicon controlled rectifiers. Say silicon controlled rectifiers. Then the 9th example of power electronics device is called the gate turn off thyristor. Get, turn on, thyristor. In short, we call it GTOs. Say, get, turn off, thyristor. Again, say, get, turn off, thyristors. In short, we call it what? GTO. The 10 example of power electronics device is called the solid state relay. Say solid state relay. Say solid state relays. Say solid state relays. In short, we call it SSR. So this is GTOs. In plural, we call it GTOs. But singular, GTO. Plural, GTOs. Singular is SSR. Plural, SSRs. So you have to add a small case s. Are we together? So those are the 10 examples. Okay, mark the 10 examples that you found. Mark for yourself the 10 examples that you found in different sources. Quickly, mark. Just put a tick. Take a pencil, put a tick. To check what you have found and what you are supposed to find. Done? Others they didn't do, so they have nothing to mark. So they'll be keeping on writing. On writing the examples. Writing and writing. And they have to make sure that they don't finish. So my dear students, whenever you talk about power electronics devices, you have to think about either one or all of those 10 examples. These are just some of the examples. If you go in deep, you'll find also some other examples of power electronics devices. Okay? Okay? Yeah. So we didn't mention just the diodes. There are particular diodes that we categorize or use them in power electronics. Not all the diodes, some of them. Not all the bipolar junction transistors you're using in power electronics, no, some of them. Not all the field effect transistors that you're using in power electronics, some of them. Not all MOSFETs are used in power electronics, no, some of them. Others have been designed for the particular purpose. So now we are going to reinforce understanding. I know that you have pronounced it slightly or just in a distance, and then you wrote them. So maybe you have a plan to say, I will spend the whole night to just claim about these examples. But that's not the intentions of this lecture 2. The intention of this lecture 2 is actually to reinforce understanding in such a way that if I meet you on the road or you meet your classmate on the road and ask you to mention at least 2 examples of power electronics devices, your neighbors or your friends has to mention them without a doubt. Are we together? So we are going to mention or to pronounce those 10 examples of power electronics devices. Then we are going to the 7th terminology. 1, 2. So you have to pronounce them with joy, with a great joy, and with a great actual expectation. And I don't know about you, but if I could be you who have been taught, because nobody was introduced to me when I was in first year like you, nobody was told me about these stories. These are just the findings that I found myself because I like electronics engineering and telecommunication engineering. And I'm always learning new concepts. And just see, this is the one of the concepts that I've learned. No teacher who have actually mentioned about these examples. But if I could be you, I could say that wonderful. So before the end of this year, I have to know at least 5 power electronics devices. How do they work? And how do they control, convey, and conditioning electric power? If I could be you, whether I will be taught in the class or whether I won't be taught. Hello? Stand up. What did I say? I say stand up because that's what you heard. So stand up. So 1, 2, 3, go. No. 1, 2, 3, go. Continue up to number 10. So wait, I think here some of the students are not pronouncing, and it's simple to identify them. This part, pronounce the first example. The second part, pronounce the second example of power electronics device quickly. So these are the ones who have been a lazy student. This part, pronounce the power bipolar junction transistor BJT. Quickly.
Power bipolar junction transistor.
Then this part, pronounce the first example power electronics device.
Insulated PX bipolar junction transistor.
At least, but these are still winners. Then this side, pronounce the fifth example of 40 power electronics device. Quickly.
Thyristors.
Thyristors, in bracket.
Silicon control.
This side, who are still losers. Pronounce the sixth example of power electronics devices. So this is the part who are lazy. These are the losers. At least from there, back they are pronouncing. Okay, this side who are winner. Pronounce the seventh example of power electronics devices. In bracket? Eh? Okay, this side now, together combined. Pronounce the eighth example of power electronics device.
Silicon control rectifiers.
At least, yeah, they are coming, eh? On this side, pronounce the ninth example of power electronics device. Then now, the winners, I think that because sometimes you can win the match at the 90 minutes, isn't it? So we are going to close our match. At this side, pronounce the 10th example of power electronics device. Okay, so no winner at you, right? Clap your hand for yourself if you memorized these examples. Clap your hand to congratulate you have done a work. Your neighbor is jealous to other people, but also your neighbor is jealous to herself or himself. In Tanzania, most people, they will never appreciate you. They will always criticize you and let you down that you cannot do anything. Then the seventh terminology is called the electronic circuit. Why should we learn about electronic circuits? Because we'll also have, or in this module, we'll discuss about the power electronic circuits. So before we discuss about power electronic circuits, you have to understand what it means of full electronic circuit first. Because power electronic circuits, it's a one example of electronic circuits. Say electronic circuit. Electronic circuit. So we have a question. This is question number 7. What is electronics? What is electronics circuit? Ask your neighbor. If your neighbor is happy, ask him or her, what is electronic circuit? If your neighbor is happy. If your neighbor is happy, ask him what is electronics. If your neighbor is unhappy, then that's none of your business. Don't talk to him. Because your neighbor is full with his stress of 40 binary number. In terms of 40 mil system. In the morning, the binary number is 0. In the afternoon, the binary number is 0. And in the evening, the binary number is 1. So that might be a problem of your neighbor. And it's okay in life because you don't die. Again, ask your neighbor what is the electronic circuit, regardless whether your neighbor is happy or unhappy. Then what? So your neighbor say, wewe, hebu niache mimi na electronic circuit yako. That's what the neighbor is saying, indirect, internally. The electronic circuit. Electronic circuits in Bongo. Electronic circuits in USA. Then electronic circuit, say again electronic circuit. Say electronic circuit. Is the type of electrical circuit that is used or that uses electric and the electronics components, such as resistors, such as capacitors, such as diodes, such as integrated circuit, we call them IC or IC, such as transistors, op amps, to do what? To process electric signals, and perform specific functions. That's the simple definition of electronic circuit. Hello? What is electronic circuit? In other words, you may define electronic circuit as what? Electronics circuit is composed of individual electronics components, such as diodes, such as resistors, such as capacitors, such as inductors, such as transistors, which uses individual electronics components such as diodes, which are interconnected by conductive wires or traces. So traces are interconnected by conductive wires or traces for the flow of electric current. So these are the two definitions of electronic circuits. Again, class say electronic circuits. Again, say electronic circuits. Say yourself electronic circuit because you didn't say twice. Again, loudly. Again, loudly. Electronic circuit. Say electronic circuit.
Electronic circuit.
So stop writing. What is electronic circuit? You may define in different style, but you may use this either of these two styles. Allow I say this, stop writing, listen and watch on the blackboard. You and your friend, something is going on there. You are lost in this class. Including somebody who wears spectacles at the back bench. So electronic circuit, this is the type of electrical circuit. We have so many types of electrical circuit. One of them is electronic circuit. In installation, we have wiring electrical circuit. So in wired electrical circuit, we don't have any semiconductor. We just have electrical components, such as switches, such as lamps, such as sockets, etc. We have trunks, we are using trunks and what? We have trunks and conduits. Actually, to allow the flow of electric current from one point to another point. Then, in case of electronics, this is the types of electrical circuit that uses electric and electronics components, such as resistors, capacitors, diodes, integrated circuits, transistors, op-amps, to process electrical signal and perform specific function. In electronic circuit, we have a specific function for each electronic circuit. Then the second definition says that electronic circuits is composed of individual electronics components, such as diodes, resistors, capacitors, inductors, transistors, which are interconnected by conductive wires or traces for the flow of electric current from one point to another point. Those are the two definitions of electronics circuit. So simply in these two definitions, stand up. In these two definitions, first of all, we have electronics component. Say electronics component. Keep quiet. Today he's on the duty. Stand up. Tomorrow you will be on duty. Stand up, please, my brother. Okay. So say electronics component. So what do you expect whenever we have electronic circuit? We expect it to have some electronics component. If you analyze, stand up. Okay, then. Okay. So, in these two definitions, what are the keywords? In an electronic circuit, we expect to have electronics components. Say electronics component. We call them electronics components or electrical and electronics component. Say electrical and electronics component. So ask your neighbor, what's the difference between electrical components and electronics components? So answers your neighbor's question. That is basic electronics. You have to know what is electrical components and what are the electronics. So can you tell us? You didn't cover it yet. Did you cover that concept? Not yet. So here it's a difference. Listen. Electrical components are the electrical components, or these are the components which actually conduct or allow the flow of electric current by using only electrons. While electronics components are the components which allow the flow of electric current through them by either or by using electrons or holes or the combinations of electrons holes. Jamani, hiyo ndo basic electronics, hicho ndo tunachowafundisha wenzenu wa diploma. Nyinyi mlisema twende A-level, si ndio eh? Sasa mbona hiyo hamjakutana nayo? Kama hujakutana nayo uitafute. Google si ipo, bando si lipo. Sema ndo hujui unatafuta nini. So for that case, in these examples of electrical and electronics component, a resistor is not electronics components because they allow the flow of electric current by using only electrons. A transistor is electronics components because they allow electrons by using electrons, or it allows the flow of current by using electrons and holes, because it's semiconductor devices. When you talk about electronics devices, most will talk about semiconductor devices. Those materials which have semiconductor material. Because you have three types of materials or electric materials. We have conductors, we have semiconductors, we have insulators. So electric components are made by conductors. Electronics components are made by semiconductors. That's another difference. Example of electric components: resistor. Say resistor. Say resistor. Capacitor. Inductor. Those are the electric components. However, that we are using them in electronic circuit or in electronic system, but they don't have semiconductor material within it. Example of semiconductor. Say example of semiconductor. Say example of electronics component. Diodes. Say diodes. Integrated circuit. Op-amp. Transistors, etc. Even oscillators, etc., etc., etc. Those are the semiconductor or electronics component. You could not say that I am an electronics engineer while you don't know the difference between electrical components and electronics. So then, that's number one. But number two, then those electronics components, what the main function of those electronics components? To process the electric signal. Say to process the electric signal. Say to process electric signal. When we say electric signals, we mean that to process electric current, to process electric voltage, to process the frequency, to process the electric power, to process the gain, to process what again? My neighbor has got stuck. So 1, 2, 3. Read the first definition quickly. 1, 2, 3. Go. No. Start with electronic circuit. So 1, 2, 3. Electronic circuit. Functions. That function one is disturbing me. So then let me end this lecture 2 by mentioning 10 examples of electronic circuits. Then we'll meet tomorrow. That lecture 3, where I will discuss only 3 terminologies of power electronics in detail, so you can have a good Friday. Those. Get prepared. The next lecture, lecture 3, will be tough a little bit. Get prepared in your mind. So, 10 examples of electronics circuit. Electronic circuits are the first example. Be careful in examples of electronic circuits. You may mention a type of another type of electronic circuit. Be careful. The first example of electronic circuit is called the analog electronics circuit. Say analog electronic circuit. Say analog electronic circuits. In this semester, we have a good news. You have a good news. You are learning a module called the Fundamental of Analog Electronics, which have been taught by Mr. Asumani Omari Mfinanga. So in that module, you learn about the analog electronics. The second example is called the digital electronics circuit. Say digital electronics circuits. Say again, digital electronic circuits. Then this one, digital electronic circuits, you will learn in semester 2. That's a module that called the Fundamental of Digital Electronics. You will enjoy digital electronic circuits more than what you have learned in electronic science in A level. You just have introduction of logic gates, but here actually be discussing a lot of details. and what those logic gates process. Then the third example is called the power electronic circuit. Say power electronic circuits. Say power electronic circuits. So I will teach you about power electronic circuits as one of the sub-enabling outcome. If you do still remember about sub-enabling outcome, ask your neighbor, do you remember sub-enabling outcome? Then the first example is called the radio frequency or RF circuits. Say radio frequency circuits. Say radio frequency circuits. You have a module that's called the practical electronics. In that module, I think that one of the circuits you learn is called the oscillator circuit. Oscillator? Yes, you learn about amplifier, but later you learn about oscillator. What is? Oscillator circuit. But even in analog, you also learn oscillator circuit. So oscillator circuit is a good example of RF circuit. And the RF circuit, these are the electronic circuits that we are using in telecommunication. Say in telecommunication. When you talk about radio frequency, it's the one spectrum of light. How many spectrums do we have in light? 7 spectrum, right? The first one is called what? Radio frequency. The second is called what? Microwave. Say microwave. The third is called what? Not ultraviolet, infrared. Say infrared. And the fourth one is called what? Ultraviolet light. Then the fifth is what? Visible light. Then next is what? Gamma rays. And then you have what? X rays. So in telecommunication, we are only using 4 bands of light: radio frequency or radio wave, microwave, infrared wave, and visible wave. Whenever you hear about optic fiber, and I think that you went to some of the industries for the study visit, optic fiber, actually those are the materials allowing the flow of light. And that light is visible. But with the speed, it means the signal will be transmitted with the speed of light. What the speed of light? 3 exponent 8 meter per second, aka 3,000 or 300,000 kilometer per second. That's why you can make a call and you can call your father when you are in Dar es Salaam, and you can call your father who is actual in Kigoma or in Mwanza. And within a fraction of a second or within few seconds, you hear your mobile phone is ringing. It means the signal has been transferred or transmitted to Kigoma or transmitted to Mwanza, and then it has been received. That's why you can establish the conversation. So without optic fiber, we couldn't have. Because the signal will be transmitted 300,000 kilometers in 1 second. From here to Mwanza, how many kilometers? Few thousands. From here to Kigoma, how many kilometers? Few thousands. Not 300. Yani kilomita milioni 300 kwa sekunde moja. Ndio mwanga wa jua unasafiri. Muulize jirani yako, unasafiri kwa spidi gani? Anakuangalia tu. Muulize, unasafiri kwa spidi gani? Amekwambia nani anasafiri kwa spidi hiyo Kwa zile ndege za wanga, si ndio kwa anasafiri usiku. From here to Mwanza within what? A fraction of second. Jamaa amefurahi, anaelewa hayo mambo. Then fifth example of electronic circuit. Say fifth example. Jamaa anaelewa. Then we have electronics communication. Electronics communication what? Circuits. Say electronics communication circuit. Say electronics communication circuit. Yes, if God wishes, I will teach you a module that called the communication. Wait. Send up electronics communication laboratory in 2nd semester. Then the next example is called the electronics sensors circuits. Say electronics communication circuits. So if God wishes, and I will be alive and will be alive, maybe in the second semester, I will teach about electronics communication circuits. Will you enjoy it? Yes. Yeah. I think you will pray that for me not to teach you, isn't it? No. You'll pray that for me to teach you? Yes. Okay, let us see. Then say electronic sensor circuits. Say electronic sensor circuits. So, in electronics, we have hundreds sensors. Say sensors. Say sensors. And sensor is actual nothing from your biological body. How many sensor organs do we have as a human being? 5. The first one? Eye. So in electronics, we have a camera representing an eye. Then the second example. So a camera is a sensor. The second example, ear. So in electronics, we have microphone sensors to actually to hear the sound. Then another example, nose. So in electronics, we have smoke sensors, or we have actually we call them test sensors, or we call them test sensors, or we call them what? We call another names that we call them what? Test sensors, and even we call it, yes, I forgot this phenomena. But you have so many sensors in electronics, which actually that are formed in electronic sensor circuits, which perform the actions of sensing. Say sensing. Another example is what? Test. Tongue. Is this it? We have a lot of electronic sensors that actually test the signal available. Just like your tongue. Ask your neighbor, what do you like to test by using your tongue? Do you like to test the sugar, the amount of sugar in tea, or the amount of salt in vegetables? So ask your neighbor, which one do you like? So similarly, we have sensors to test on your behalf. So you can use a sensor to test the amount of food, sugar. You are not sure. So say electronic sensor circuits. Then the seventh example is called the timing and the control circuits. Say timing and control circuits. Say timing and control circuits. Ask your neighbor, do you like to set an alarm? Sit. Ask your neighbor, do you like to set an alarm? So an alarm is a good example of timing circuit. So it will measure the time. When you tell an alarm, wake me up at 4 a.m. the alarm will wake you up. And you know what will you do? You say, alarm, I'm not ready. I'm not ready. Alarm, wait a moment. I will see you later. Alarm, I will see you later. Not now. Now let me enjoy my night. Then the 8th example is called the mixed signal. I'm trying to mention these different types of electronic circuits actual to challenge you. You may go and learn each type of electronic circuits that I've mentioned, because at least you have something to go and learn. Before you didn't know. Ask your neighbor, did you know those circuits? And then tell your my neighbor, be faithful, be faithful. Did you know those circuits? No. Say mix the signal circuits. Say mix the signal circuits. Another type of electronic circuit is called the linear electronic circuits. Linear electronic circuit. Linear electronic circuit. Linear electronic circuit. Another example is called the non-linear electronic circuits. Then let me give you a bonus. Number 11 is called the opto. We have also some circuits, we call them optoelectronics circuits. Optoelectronic circuits. Then the second bonus is called the power supply circuits. Power supply circuits. So we have 12 examples, not 10 examples. We have 12 examples of electronic circuits. So optoelectronics, first of all, it's called the optoelectronics. This is the circuit which is processing electric signal in form of light. Stop writing. Look on the blackboard. Stop writing. Look on the blackboard. Say optoelectronics. So optoelectronics, this is the type of electronic circuit that actually process electric signal in form of light. That's the point where we find about the fiber optics. Okay? Or optic fiber. Transmitting electric signal in form of light. Remember that energy can neither be created nor destroyed, but it has been transformed from one form to another. So these are the circuit actually transform electric signal into light signal, and also transform light signal into electric signal. That's what I was mentioning. This is what I just means that in optoelectronics, it can be combined with radio frequency circuits and electronic communication circuits, actual to make sure that, or to guarantee fast communication. Fast what? When you talk about power supply circuits, actually this one you may find in your mobile phone adapters, in your computer adapters, right? In almost all electronic devices. When you talk about non-linear, we have linear and non-linear. Say linear and non-linear. Yes, if you do remember that, you learned in case of operational amplifier, you learned about the linear graph and non-linear graph. Do you remember that? Do you remember that? So when you say that, you don't remember. When you talk about the linear electronic circuits, actually these are the circuits processing electric signal which can be written as a linear function. When you talk about non-linear function, it means process electric signal which can be expressed in terms of linear function, can be expressed in another function. So now, reinforce understanding. Close your exercise book. 1, 2, 3. So we go in position. So this part. 1, 2, 3. Say analog electronic circuits.
Analog electronic circuits.
Keep quiet. Say again, analog electronic circuits.
Analog electronic circuits.
This side. Digital electronic circuits. Keep quiet.
Digital electronic circuits.
Good, maintain it. Say power electronic circuits. This side.
Power electronic.
Good. Say radio frequency circuit.
Radio frequency circuit.
Wonderful. Say electronic communication circuits.
Electronic communication circuits.
Say electronic sensor circuits.
Electronic sensor circuits.
Say timing and control circuits.
Timing and control circuits.
Say mixed signal circuits.
Mixed signal circuits.
Say linear electronic circuits.
Linear electronic circuits.
Say non-linear electronic circuits.
Non-linear electronic circuits.
Say optoelectronic circuits. Say optoelectronic circuits. All the students say power supply circuits.
Power supply circuits.
So did you understand today's lecture? Is it clear?
Yes.
Did you understand?
Yes.
So now mark, because you did it the homework. So mark your homework. Mark yourself. Mark what you have found. Because that's the marking scheme. That's the marking scheme. That's the marking scheme. My neighbor here does not have something to mark. You have? So mark what you have found. It might be different. It might be the same. Hello? Mark what you have found. Yes, see, our Sierra was not in the class. He went out. He was in deep thinking. What's your final score for terminology number 6 and terminology number 7? 100 over 100, eh? Not 0 over 100. Can you show your neighbors the score? Because you always say that Simba won the match, Yanga lose the match. How about you? Even you say you used to lose the match in the class. So I think, okay, I believe that you have understood this concept. We just covered some important terminologies. Make sure to remember it for the rest of your life, because once you remember it, then I believe that your journey of learning might be simpler and simpler and simpler. If you don't understand these terminologies, you'll be just confusing them and you'll be misusing them. But I think from now onwards, you'll have a clear understanding and clear difference. This is terminology number 7. I would like to welcome in lecture 3, when we'll be discussing about other 3 terminologies in power electronics. And after that, we are going now to start another topic. So let's say this is the end of lecture 3. Welcome lecture 4. And I can just give you the terminologies that we are going to discuss so that you can go through them before you come and discuss. Okay? So the first terminology that we are going to discuss is called the power electronic circuit, right? In the next lecture, we are going to discuss about power electronics circuits. Power electronic circuits. And then after we discuss, we'll mention 10 examples. Or we'll mention what? Which examples? Let's say 10. Then we are going to discuss about power electronics drivers. Say power electronics drivers. Say power electronics drivers. Then we'll have examples. And the next terminology after that, we'll be discussing about power electronics converters. Power electronics converters. Power electronics converters. So do the private study before you meet in the next lecture. And mention 10 examples or 10 types of these power electronics converters. So power electronic circuit, say power electronic circuit. Say power electronic circuit. Loudly say power electronic circuit. Loudly say power electronic circuits. Good. Say power electronics drivers. And power electronics converters. So from there, you are ready to get into other topics in detail to discuss about those semiconductor devices that actually will be processing the high currents and the high voltage. So this is the end of lecture 2. I believe that you've understood. In case you have a question, let me know. And if there's no any question, at the end, I would like to welcome lecture 3. Make sure that you have a fresh mind. I want to tell you that we are going to encounter new terminologies in this. It's a new concept for most beginner students. Make sure that you have a fresh mind and you have a good target and you are actually passionate on that. Otherwise, I'll be discussing and you'll forget everything. Okay? So if you've understood, now time for me to appreciate you. I don't know if you appreciate me for teaching you. But anyway, I just thank God who have given me a chance to teach you. And really, I enjoyed the class, right? Yeah, so I enjoyed the class. I believe that God will also help me to teach you in this style or even in the best style rather than this one in the next lectures. Right? So I appreciate you. You have been concentrating. You have been listening. You have been making a follow-up. You have been cooperating. Keep it up. So now it's the time to congratulate you. Quickly. 1, 2, 3. Hongera. Imareni. Wow, in power electronics. Thank you very much. See you in the next lecture.
Yes.